This video is going to look at how to map county level data in Google Colab. This is going to show how Jupyter Notebook, in this case Google Colab, provides tools to map data. Within Google Colab, it is possible to read in shapefiles, merge key variables, and make a dynamic map based on data that you want to explore. The basic steps we're going to go over. First, I recommend reviewing and attempting to replicate the examples. The examples include this GitHub that we're going to detail walkthrough. There's also some other examples, one on ICPSR and one on Design Safe. And these examples provide more details for the example that's on GitHub, which we will go over. I'm just going to show it here. When you go to GitHub, one thing to know, sometimes whenever you load up a notebook, initially it doesn't want to load and you might have to click reload. Sometimes I've noticed 3 or 4 times before it actually opens, but we'll look at this example. The example that's on OpenICPSR has a PDF version of a Jupyter Notebook that's easy to look at online. And this has a lot more details about how to navigate Google Colab, information about Census API for obtaining data, more information about Python packages, definitions, and walks through this in a lot more detail than what the example we're going to look at in this video. And then on Design Safe, you can also look at this one particular example, Census API download. This is for a city in Missouri, Joplin, Missouri. And again, this Google Colab, or this Jupyter Notebook, which is will not work in Google Colab, but this Jupyter Notebook has a lot more detailed information about some of these steps, and there's a lot of similarities between the 3 notebooks that are in the example motivating examples to look at. So for this example that's in Google Colab, you can click on the Open in Google Colab button. This will open up in Google Colab, and you can run it from here. This is one option for running it. For the example that we're going to look at, just so that I can show how it works with some of the steps, I'm actually going to run this notebook from my work folder in a project that I'm using Google Drive for desktop. So I've got access to this notebook. I've copied it to my folder on my computer, and I'm going to open it in Google Drive. And what I did there is I just right-clicked on the file that's in Google Drive for desktop. This is linked to my Google Drive, and I opened it up in Google Drive. So just showing this is the same notebook that's on GitHub, and I've got this in a folder on my computer. As an overview, we're going to look at how to set up the notebook environment, the packages that need to be installed, setting up the working directory, which is important for using this example with data that you might have in your own project folder. Looking at how to obtain data. For this example, we're going to use the Census API to obtain data, and also using the Census Bureau's website to obtain the shapefile data. We're going to do some basic cleaning, merging the shapefile with the data file, checking the variable that we want to map, checking the map projection, and then setting up the map and mapping the data. So I've just opened this in Google Colab, and I need to run it. The first time I get a little warning just saying, do you really want to run this? And I do. Google Colab does not have this package called GeoPandas. GeoPandas is a package that makes it possible to look at data that has spatial information, so shapefiles. And you can add this to Google Colab by using this first line command, which needs to be run first. After you've installed GeoPandas, the rest of these packages are already included in Google Colab, so we don't need to add them. And it's always a good step to check to make sure that your packages are what the format, what the versions are. You might be watching this video a year from now, several years from now. You might be using a different Jupyter Notebook environment. So just important to know what the versions are for the packages that we're using, because sometimes versions change and the options change, and that might create some replication problems. It's always important to check your working directory. If you don't run these steps, this program actually will run without changing the working directory. But in this case, if you click over on the left, you can see what the files are. So if you don't change the working directory, the folder that you're actually in is this content folder here. So that's checking the current working directory. This is the folder you're in, is in content. It's nice to be able to actually use files that are on your computer or in your Google Drive. And to do this, you need to mount the Google Drive. And in this case, we're mounting it to the content folder and drive. And in a second here, you'll see that the word drive, the folder name, is going to be added over here to the content folder. To mount the drive, you'll have ask a couple questions. I'm going to hide this for a second because I think that the actual code that it shows is something I don't want to share publicly on the internet. But I'll be able to paste in my authorization code. And then once the authorization code is set, Google Colab will give a message saying that the drive has been mounted. And we can see over on the left that now there's my Google Drive is over here. So I can actually see my drive, my shared drives. These are my personal drives. I want to change the to a folder on my computer in my Google Drive. So in this case, I'm changing to a project folder called Template Workflow. This is for a course that I teach in the Department of Landscape Architecture and Urban Planning at Texas A&M, a course on data analytics. When I look in this folder, it's nice. I can see what the current folders are in this directory. We've got a bunch of work folders, a bunch of files. And I want to actually set the working directory to my work folder, which I set to work NPR. And I can check what the current working directory is, and I can see that I'm in my template workflow project and in my work folder. The reason why I've got this set up this way, I like to use relative paths in my programs, and I don't want to have to retype the current working directory in the future. I also want to make sure that this program is transferable to someone else's computer who might have a different folder setup. So this is just a nice option for getting the working directory set up. Again, these steps really, for this particular program, you don't really need these steps, but it's important steps if you're going to use this program for a different project and where you have different data that you want to obtain. For here, we want to obtain first the data that we want to map, and then the shapefile data. This is a short example, and if you'd like to see more details on how to use Census API, the examples, the motivating examples that I shared earlier from OpenICPSR and DesignSafe have a lot more details. In this case, I'm just doing a quick way of accessing the 2010 census, decennial census for the state of Texas, and obtaining data is related to the total population and population by race and ethnicity. So as I run this, we can see here that it's I outputted made a hyperlink that accesses the API data. You can click on this hyperlink and see the data for, this is Texas and the counties in Texas and the population data, plus population by some race and ethnicity characteristics. So this is what the data is that we're going to map. Now that I've got the hyperlink set up, the Census API, I can request the data to get the data from the hyperlink. This step here is important for setting up the pandas data frame, and then I'm adding an extra variable that identifies the survey that the data is based on. When I look at the top 5, the head of the data frame, we can see that in fact we have data for Texas and the county and this information here. Just as a quick example, if I wanted to do this for a different state, say California, which is FIPS code 06, I could change the state, change the link. We can see that now we're in California instead of Texas. Run this again, and the data is for Texas. Instead of Texas, it's for California. But I want to run this for Texas. So I'm going to go back, run. And we have the data for Texas. I'm going to copy this data over just to a new data frame. Just to be clear, this is data to map. I could have named it anything, but I like naming data frames in a way that makes it clear. I also like this convention of putting _df or df at the end of the data frame to remind myself that this is a pandas data frame. Next, I'm going to obtain the shapefile data. One of the nice things about GeoPandas is the ability to read in a zipped shapefile. And what's nice about that is I don't have to unzip. I don't have to use any other commands. I basically am going to go to this website, look for the and read in this file that's on this website. The website that we're looking at is www.census.gov, which is a source for all kinds of data from the Census Bureau, ACS data, decennial census data, economic data. They also have all of their tiger files or shape files. So there's a directory that's important to look at. You can see all the different shape files you could read in. In this case, we're reading in the geographic cartography files from 2010. This file, there's lots of different options for here, but these geographic cartography files are simplified representations of selected geographic areas. And they're nice for doing quick maps where you don't necessarily need to see lots of detail. They're simplified, improved appearance of geographic areas when displayed at small scales. These are not meant to be used for any kind of analysis, geocoding, or any kind of precision, but it's good for web mapping and being able to see the data in a rapid, low bandwidth option. So we can see we want to get the data for counties. The county data is 050. That README file is where I've learned that. And we're also getting the data at the 5M scale, and that's just a nice kind of option for the reading this from the internet. So the 5M is 1 to 5 million, and the FIPS code or the summary level code is 050 for the county. But there's also places, cities, metropolitan areas, school districts, lots of different options for what you might want to map. And this is also data that you could change the API to get the data at a different geography. So I've given this information to go and look at this, where the website is, and then the data, the shapefile to map. I'm reading in the zip file that I just mentioned, and I can make a quick plot of the map to see that it looks like, yes, in fact, this is all of the counties in the United States. And whenever I look at the data, I see here I've got my GeoID, state information, and then this geometry information is what's important for the map. Important to recognize is that from the API, we also get GeoID, and the GeoID here, and these are, since these are county level data, we can see it starts with 050. As we can see here, 050. So these are at the same geographic unit of analysis, and they have the same GeoID structure. So that's one of the things you have to make sure your data has either the data that you want to map and the data, the shapefile that they share a common ID that you can merge on. The GeoID is what I'm using to do the merge. Your data might have a different ID variable in the data that you want to map, or and the shapefile. In this case, I'm merging the shapefile is my left data, and the data to map is my right data, and I'm bringing these two files together on the GeoID. Whenever I run this, I now have GeoID, the geometry data from the shapefile, and also the data that I actually want to map, which is the population information. To map the population information, I need it to actually be a number. And initially, when Google Colab reads the data in from the Census API, it's not a number, it's an object, or might also be called a string, but it's not a number. So when I look at the variable, I want to change the variable from its current object type to an integer, and that's this line here is creating a new variable called total population that's based on the P005001 but making it an integer. When I look at the summary statistics for total population, now I can see I have mean, minimum, standard deviation, percentiles, max, and these are now this is a number, and I know it's a number because instead of getting the count and the unique and the frequency top, I'm actually getting the summary statistics that you would expect for a number. I also want to check to make sure that the map is in the correct projection. Initially, the data is in NAD 83, EPSG 4269. Technically, Folium needs the data to be in 4326, which is for a web map, which is WGS 84. So this is, you'll need to have at least some basic information, knowledge of GIS mapping, but this is technically what you need to make sure that your data is actually in the right format for it to map correctly. Now the data is cleaned and I'm ready to set up my map. Folium needs to know some basic information, and this is a helpful, just to generalize it so you can see in the data what the minimum and maximum values for the like the different shapes in the data. And we can use this bounds command, bounds option as a nice way to get the center of the map. So where does the map want to be centered on? So this data file is the center of the data is roughly 9.8. This is the latitude and longitude for the data. And whenever I pass this information, Folium needs to know where the map needs to be centered, and it also needs to know some zoom level, which you can change and make it closer in or zoomed out. A couple other things on here. I'm putting in the geodata, which is the merge data file. The data itself is also the merge data frame. The columns that I want to have in the map is the GeoID and the total population. If you have other variable, you would need to change this depending on your variable name. I need to key on the GeoID. This is a color path map, so it's going from yellow to blue, so I could have changed that if I wanted to. The name is total population. This is 2010. I don't have the legend turned on, but if I had a legend turned on, there would be information on total population. And then I'm adding this to the map, and then I'm displaying the map. So we've got a nice quick map of the counties in Texas, and looking at population, total population by county. And as we can see, just as standing out, Houston, as we would expect, is the county with the most population. When you're finished, you can save the map as an HTML file. You can also save the map as a geodata frame. Because I've got this set up in my template project folder, the HTML file that I created should have shown up here, but I'll come back and look for that in a second. So as I hadn't clicked the button. So I click the button here to save the file, and then if I look in the current working directory, I see here I've got the HTML file. I like to put the date on it so I know if it's a different version. And then what's nice about these HTML files, I can open up a new browser on my Google Chrome or and I can drag and drop the HTML file into the browser, and then basically I have a nice web-based dynamic map of my data. So it makes this is something that could be shared on a website or shared with people on your team, and it just makes a nice way to explore the data. You can also save the data as a shapefile. I'm not doing that right here, but that's also lots of ways you can export the data from Google Colab and use it. So this concludes the video, and looked at how to set up the environment for Google Colab, what packages you need to install. Main thing here is GeoPandas. Setting up your working directory is a nice thing to do so that you can use relative paths, and you can actually access data that's not from the Census Bureau. It might be in your project folder. Looked at what basic steps you need to obtain the data you want to map and the shapefile you want to map, how to merge the shapefile with the data file, checking the variables you want to map, checking the map projection, and setting up your map, and then actually producing the map for your data exploration. I hope this was helpful.